All right, hello back to containers. We were talking about set, and that is what we ended on. So let's continue with set. So I have copied what I talked about last time, what I wrote last time on sets. So let's open that back up and add to it now. So we learned about insert, we learned about count. Sets keep track of things, and we can put multiple things inside. We can insert 2, then 1, then 3, and it's all here, but it's actually in order. If you can think about that, it knows the order somehow. It knows that like this is the order of all the elements, which is very interesting and useful. At some basic level, inside of the set cloud, whatever S is, whatever its ADT is, it responds to these things. It also knows about the order of the elements. And the order comes out when you do any kind of traversal of that set, any kind of iteration through that set. So, let's see here. Yeah. So there's a few ways to do it. Usually, if you just iterate through a set, you can go in order. There's also some other operations that we haven't talked about, like lower bound and upper bound. So the first thing that lower bound does, or the one thing that it does, is you give it a value, and it tells you the next thing, a lower bound of the rest of all the things after that. So it gives the first element in the container, which is not considered to go before value. That is a lot to think about. We'll give examples of those in a second. Begin and end, though. Those work in the exact same way, what do you know? But the order is interesting. So notice that I put these in, not in order. I did 2, then 1, then 3. I can make it even extra out of order by putting 2, 3, then 1, right? Let me use iterators now. So again, you have the range-based for loop. It can be like for int x in s, cout x space, and then give a new line. It's all well and good. Oh, it didn't save? There it goes. So we'll say g++, can I? Yes. Sets. What? It gives it back in order because of the orderedness of the iteration, of the iterators. So give back the values in order. Okay, so that's very nice. And remember, you could spell it all out. You can be like for set of int iterator it equals s.begin, it is unequal to s.end, it++, and it just knows about the order. And instead of x here, it's star it. It just knows the order. And they can easily go through everything quickly as well. So it knows the order. One thing that most people do is they don't say like set int : iterator all the time. They use auto for that. So most sane people like to use auto for these things. I've just been spelling it out for you. Because there's a lot to type, right? The compiler can figure out what needs to go here. It's the return type of s.begin. Obviously, put it there. Put it there for us, please. So it's the same thing, no different. And then, if you don't want to iterate through, but you still want to get some of the order back, you can use these lower bound and upper bound things, which kind of work counterintuitively. So what a lower bound returns is the first element in the container which is not considered to go before value, which is a weird thing to do. It's either going to give you back an iterator to the value itself, and then you can start from there and start going in order using that iterator, plus plus and things like that. Or it's going to give you the thing that's right after the value that you're searching for. So potentially you could be like, okay, I want to start iterating from maybe 2. So let me get an iterator to 2, and then I'll have like skipped half the thing. So I can say, I don't know, let's iterate from 2 onwards if we can. We can say for auto it equals s dot lower bound, and then the rest is the same. It is equal to s dot end it plus plus. So what this is going to do is it's going to oh, sorry, I want the lower bound of, let's say, 2. So it's like start iterating from 2, and like skip part of the set. So that's one thing that I can do. That's all this stuff is logarithmic time. It's super fast, super beautiful. If anything's not making sense, it will be made to make sense in 41, I promise. So like, it's, yeah, start at 2, let's iterate through the rest of this set. We can do it very quickly. Or you can be like, hey, what is the element that comes after 1 in this set? And for that, you can use upper bound. So these names don't really make a lot of sense. It gives an iterator pointing to the first element in the container, which is considered to go after value. So what comes after 1, I can say cout s dot upper bound of 1. What comes after that? Give me an iterator back, and I can dereference it. Boop. Boop. The 2 is the next thing in the set that comes after 1, and maybe if I didn't have the 2, it would give me the 3. It would know. Like maybe I had, instead of 2, I put 5. Like it knows the difference. If I did that, suddenly the thing that comes after is 3. Isn't that fun? Okay, so that's sets in a nutshell. It knows its, it just knows its order, which is very nice. This is apparent when you iterate through the elements of the set. So if you ever need order and you need insertion and retrieval and erasing very quickly, think about using sets. The next thing, map. So this one's actually really easy because I just talked about sets. So let's go to it. Dun, 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 map. So there's also a multi-map. We don't have to get into that. So a map is exactly like a set, except the values that it holds are pairs, indexed. So there's 2 types to make a map: the key type and the value type. You can say, I want a map that maps, I don't know, int keys to string values. And this can be a phone book. It gives you, or sorry, phone book's the other way around, isn't it? It takes names to phone numbers. Yeah, we can call it phone book. So this is a map. Maps names, strings, to numbers. Phone numbers. We can use that, and the maps are still ordered, just like sets. But they're ordered based on the type of their keys. Okay, so that's a lot to talk about, but let's talk about how you might use a map. It is a cloud, and it's got, okay, map, here's my map M. It's from strings to ints, call it M. It can respond to, hey, M, please insert into my phone book the fact that my number is a certain phone number. Okay, so we can do it like this. Let me show you. So you can either use insert or emplace, and actually emplace is a bit easier to talk about. So I will just use emplace instead. So we can say m.emplace we can say Lawton, and we can say that my phone number is, I don't know, 8675309. And that will put a pair inside of this map somehow that associates my name with 8675309. And you can look stuff up inside of a map. Given a key, you can look up its associated value very quickly. That's what it's good for. So I can ask now, I can ask the map, hey, m dot, let's go to that function now. You can say m dot at if you know it's there. Usually you'd use count first to make sure it's there. So m dot at Lawton. So give my name, what is Lawton's number? Ask the map and it will give you back 8675309. That's a really nice property of a data structure to have. So this maps are very useful for some things. They allow you to associate keys to values. Okay? They map keys to values. Let's say this here. A map maps, we say, keys to values. Sorry for using map twice, but that's legitimately what's happening here. And this is a weird looking comment, so let's do that. There we go. Okay, so that is map in a nutshell. Let us try to use it now. So it's all very similar to sets in terms of its speed. It's just as fast. Oops. So let me show you this before we go back. So remember, it's still going to be stored in the same way. It's going to order the keys in a certain way, and it's very fast to get anything out of this map and to put things into it as well. So that's very nice. And yeah, that's essentially all I want to say before we give some examples. How about just maps are just as fast as sets? That's an important thing to realize. Okay, so let's make a map. So my map is going to take strings to ints, and it's going to be a phone book. I'm going to need string as well. And so now I can insert, I can write the phone book. So you can say, all right, phone book dot in place Lawton with 8675309, and I don't know, Lawton's cat got the next number, and let's say my mom got the number after that. How about that? So now I can look up any of these people. We can look up the phone number of any of the people stored inside the map using their names, and the keys were names. And by names I mean strings. Okay, so I can say cout, well, phone book, if we're certain that this thing is there, we can just immediately go there. Phonebook.at Lawton, and it will give me back my number very quickly. No, oops, did I not compile it? No, I didn't save it. My bad. Hey, so it works, and let's see. You got to make sure that it's there though. So like Lawton space, that's not in the map, and that will throw an exception. In fact, if you try and do anything without looking it up. So you should make sure to. Usually, it's good practice to ensure that the key exists in the map before looking anything up. And so we could say if phonebook dot count Lawton, if that is greater than 0, if it's not equal to 0, I guess is the idea. Probably easier to make sense of that. Then do the thing. Okay, make sure it's there before actually looking it up. Then we won't get an exception. Or you could just catch the exception if you wanted to. That's one way to do it. Or you could be like, you can just go for it. Try cout phonebook.at Lawton. Like my dad's number is not in the phone book right now, so we could say, we can try and look it up, but it's not there, so we'll catch just any exception. What kind was it? It was an out of range exception. We can say, oh, sorry, the key, like, his dad, does not exist in the map. And maybe a new line. There. So 2 ways to try. Like, you could make sure the count's there, or you can just go for it and catch an exception if it's not there. Bam. And then you can just look up anybody now. You could be like, okay, what is my cat's number? And it knows it, and it goes and looks it up, and it prints it out. And in fact, everybody is ordered. There's a certain order to strings, if you remember. In dictionary order, essentially. And that's the order you get when you print it out, when you iterate through a map. The issue now is that you get different things when you iterate through a map. So let me, how do I want to do this? Let's say, let me do the full iterator version first, because it's very interesting what it's about to do for the range-based for loop. So let me iterate through a map where you begin and end just as normal, but this time we get back a pair of things. Okay? We get back a pair of things because we have a key and a value that we can inspect. Okay? That's the one difference between maps and the other containers iterators that we've been looking at. So for map string int iterator it equals phonebook.begin it is unequal to phonebook.end it++. So it'll go in order of like names, and I think it'll go exactly in this order because like blank is less than probably apostrophe, and then it'll go cat then my mom because C is less than M. So we'll say, so you can't anymore say that, you can't just say star IT. Dun dun dun. It's going to say, in its very nice way, remember the meme at the beginning of this lecture slides. Okay, this is ridiculous. Let's scroll up and see what it's complaining about. There's no way to output star IT because it's not a string, it's not an int, it's a pair of them, of both of them. So IT is now a pair. its first element is the key, and its second element is the value. And those are the technical terms. So I can say IT, and it's a pointer. I need to dereference it and get its first element. I say IT arrow first. And that is mapped to IT, well, you can do it the opposite way. I can do star, then the dot, equivalent, IT second. Okay? So that's how that's going to work. And now it'll compile. And now it'll run, and that is in fact the order that it gives back. Yeah, so it's going by key, not value, even though I also gave these the same order. So let me just prove that to you. I'm making this one 11 and this one 10. Okay, so that is the order that it's giving you back. Yeah, so it's pairs of things now, and so if you wanted to use the range-based for loop, you'd have to do it a bit differently. You'd like for, and pair is defined in utility. Dun, dun, dun. We say, this is why most people just use auto. It's pair string int p for that in the phone book. And then we can say cout p dot first colon space p dot second. And that should, in theory, do it. Sweet. So yeah, the range-based for loop, it still works and it's still easier, but the type that you get is a bit different than what you normally use, and that's why people, as usual, like to put auto everywhere. It's like, it'll just figure it out. I know that this thing has first and second, but I don't want to type this out. Auto p. We know that's going to be pair, that's why I called it p, but it saves us so much time just doing that. And so iterators once again have saved the day, remember. There is a .at for maps, but how in the world are we going to iterate through every possible value? Like, you have to think of them all otherwise. Iterators go through everything from a starting position, if you knew where to start, and it gives you all the stuff that's inside a container, no matter how it's stored. And so we've talked about a bunch of different containers now, and we've stored different things, and yeah, it's all beautiful. There's a bunch of different trade-offs. Just keep that in mind, and you'll be perfectly ready for CSCI 41 now. Okay? When you'll be implementing, at least in my class, if you take it with me eventually, all of these. Okay. Let's see here, in some form. Let's get on to the next topic for these slides. Now, SSH and SCP, which are something completely different. They're not containers anymore, but they are ways to connect to remote machines. We have a class server, remember, that's where your all your assignments are submitted to. Let's connect to it, if I can spell. So SSH stands for Secure Shell. It lets you access a computer remotely. And the way you can get on a terminal is to use the SSH terminal command. So you need to know the username you want to use to connect, and also you need to know the address of the computer. For us, it's server.lautensclass.com. If you've never used it, that's what it is. And you all have accounts. I made them for you, otherwise you wouldn't be able to submit your programs. So let's connect. And the way you do it is you say SSH, then you say your username, @ and then the name of the computer. It's like an email address. server.lautensclass.com, and hit enter, and suddenly you will be asked to type in your password and you can log in. Okay, so let me blow your mind. So I'm on my own computer right now. Like, who am I? My name, my user right now is Lawton Nichols. For you, it'll be like CSCI or something. And now I'm going to use SSH to connect to a class server. So I can use my username for the class server. It'll be your last name underscore your user ID, or your student ID. So it's test for me. I made a test one. So the username at server.lawtonsclass.com. Hit enter, and it'll ask you for your password. Type that in. Bam. Am I now on a different machine? It's like, well, welcome to all these things. We are running the same operating system as the server. That's beside the point. It tells me a bunch of cool stuff when I log in. But now, who am I? First of all, I'm this account now, and I am not on. I'm not on my normal machine. This machine's name is called Lawton's Class. The other machine name I didn't actually have displayed. I forget what it's called. So, we are in a different spot. And let me prove that to you by saying ls. And I have one file. Let me get rid of it. Start over. So I'm plopped in my home folder. This belongs to me, this folder. And you will have nothing there. You'll actually have some autograder stuff there. That's what it's like using those things. Don't touch that, please, to turn in your stuff. But those are all hidden files. Usually you'll have nothing there. And you can say, you can just start writing files on this remote machine. You can do it as you would with a normal terminal. It'd be like vim foo.txt, hi mom, blah, and yeah, right quit, save the file. Suddenly, I now have foo.txt inside of my home folder on this remote machine. I can print it out. I can be like vim foo.txt, it's there. Yeah, it is totally there. It saved what I wanted to save. And just to prove to you that it was, this is not a fluke, like it's not on my local machine, cd tilde, go to my home folder here, ls, there is no foo.txt. I was like, if I wanted to print it out, I can use cat to print it to the screen, cat foo.txt, it's not there. This is on a remote machine. It is a different place. So you can do your lab on this if you'd like. And you might be asked to do a future lab, like in a future class, using SSH. So please try to log in at least once, so that you can like get a feel for things. Like you only have access to your home folder. You can make folders inside of that folder, but you don't have access to the rest of the machine because you are not an administrator on this machine. All right. To log out, you can say Control-D, or you can just say exit. I should have given that. Exit logs you out, gets you back on your remote terminal. Bam. Let me write that down. Okay, so that's that. That is SSHing. And now we've written some files on our remote machine. Let's get them back. SCP stands for secure copy. It allows you to copy files between a remote machine and your local machine. And you can use it exactly the same as CP. Except the names of the files on the remote machine are, you have to prefix them, like say where they are. Username at server.lawtonsclass.com, and then a colon. You have to give all of that stuff before the file name. Let me get rid of these hyperlinks there. They're bugging me. Before the name of the file. So for example, to copy the foo.txt that I made on the remote machine to my local machine, I can say scp, like my username at server.lawtonsclass.com. Let me just copy all that. colon, the name of the file, where to get to it, its full path. It's in my home folder. It's called foo.txt. Copy that, please, to my local directory, where I am right now on my local machine. And that's just dot. Okay, so if I run this, it will work. Let me prove that to you. It will go across the network to that computer and copy the file correctly. Bring it into my current directory, which currently has no foo.txt. So let's ask me for my password. And bam, did it transfer the file. So now ls, what? It's there, and all is well in the world. So that's really useful, and you might be forced to use SSH in a future class. Okay, so keep that in mind. Now you know how to do it. You're professionals. So let's get into some exercises really quick, and I think we have a bit of extra time to start on the next set of slides. So your exercises that I encourage you to try are to come up with some use cases where you might want to use like all these different containers over something else. Like understand the trade-off now that you know it, and figure out like, okay, I want to do these operations on this data. This is a good example of a map, for example. Okay, and then for the brave, please try doing your next lab on the server. That would be a very, very good experience for you to have, I think. So try all those things, and then I will prepare the next slides, and we'll have a few extra minutes of class talking about those. So I'll see you in just a second. All right, we're going to have some fun now. The next lectures are going to be about not C++. So just in case you transfer to somewhere that assumes that you learned Java or you learned Python, I'm going to teach you a little bit of both of those languages, hopefully. I'm going to give you Java for sure. I don't know how much time we'll have for Python. And I will test you minimally on these things because this is right before the final, of course. So let's get started with Java, and I want to make it clear that, well, this needs a beautiful background, first of all. I do want to make it clear that you, as a C++ programmer, kind of already know Java. So once you learn one object-oriented language, you essentially know every other one too. So you should pat yourself on the back for that. And I'm going to get you started in the Java language now. It's a bit different, but very, very similar. All right, so we're going to do Hello World, of course, and it's going to be interesting, so wait for it. So the first thing that is interesting is I am not going to work in Vim for Java. I don't have the time to get Vim ready for it. I want cool features, and we're going to use Visual Studio Code for that. All right, so I'm going to make a file, though, in this folder where I want to work, and I want to make a file called something.java. I'll make it helloworld.java. So I will just make a blank file called helloworld.java. The touch keyword does that. So now I have a blank file in my current directory called that. I'm going to open that in Visual Studio Code. So I'm just going to drag it in there from the file browser. Boop. Here we are. And so what I'd like to do is, yeah, this is exactly why I wanted to do all this. Boop, boop, boop. So it's going to take some time. You should tell it to install all this stuff. Like, yes, I want it to work with Java. I want it to do cool Java stuff. It'll make your life so much easier. And I think it's taking its own time to install these things. We'll work behind the scenes. So let me start writing a little bit of Java now. Public class, let's make this larger. Hello, and need a main function. Java has main. And let's see, system, if it ever loads. It's installing things. Maybe I'll have to pause the video and come back once it's finished because it is a bit slow right now. System.out. print line hello world. So, semicolon, of course. This is hello world in Java, and it's not quite correct. It's a bit too fancy right now, but system.out.println is fine. This is almost correct for hello world.java. I've made one large mistake, and I'm about to show it to you after I talk about how you compile. So, to compile, well, hello. Why is it like this? Well, can I get rid of that? Yeah. To compile, there we go. Oh no. You use Java C and then the name of the file you want to compile. Java C is the Java compiler. This is going to be super fun, I can already tell. So, let me get this out of here and put it down here or something. Had enough of that. There. All right, Java C is the Java compiler, and let's run it. I'm going to say, Java C, hello world, not Java. Boop, boop, boop. Aha. The first error, and the only error that I've made so far, is that, well, hello is public. It should be declared in a file named hello.java. The file names matter for Java. If this is called hello world.java, this class better be called hello world, this outermost class. Okay? So, oh my. The class inside hello world.java needs to be called exactly hello world, the public class. Don't worry, I'm about to tell you what all these things mean. We're just getting started, I know. So now it'll work, now it'll compile. And what it did was it made this hello world.class file, and that is the compiled form, in a sense, runnable on the Java virtual machine. Now I say Java, well, this makes hello world.class, and now I can say Java hello world. I don't actually say the .class. This runs the hello world.class compiled file. Okay, that's the idea. So I'm going to say Java hello world now. And lo and behold, it prints to the screen hello world. Okay, let's talk about things. So in Java, everything is a class. If you want a function, it has to be inside of a class. Which is weird to think about, I know. So this is the main class for this file. It's called hello world. Okay? Now, every class has what's known as an access specifier. So this hello world class is public. It's viewable to the world, just like the public methods in any class that you wrote in C++. Hello world is public to everyone. So they could import it if they wanted to. So we'll talk about that in a little bit. Now, if you want to write a program and have it run, it needs a main function. And this is what a main function in Java looks like. It's inside of a class. Lives inside of a class for once. Lives inside the public class associated with the file. So this file was forced to be named hello world, because that's the name of the enclosing public class. All right. So the main function lives inside the public class associated with the file, and it takes command line arguments, and you can't have it any other way. Even if you don't use them. And the command line arguments in Java are an array of strings. And it's capital S for Java's strings. Other than that, it's pretty much the same. And then we're using a library that is automatically included for us. System lives inside of java.lang. That is, and this java.lang is what's known as a package, and it holds a bunch of libraries. Automatically included. In Java, we say imported. All right, automatically included for us. And then system has a out field, and out has a print line method, and we can call it with the argument hello world, which is just a normal string, and it will print that string and then a new line. That's what the ln stands for, to the output stream, to the terminal, to the screen. And so this file is forced to be called hello world.java because of this. Everything lives inside of a class. This is what a main function looks like. It has to be called exactly this. It's a public method inside of hello world. And it's also static, which means it belongs to the class and not to any object. So in Java, if you ever want to say, oh, this thing's public, this thing's private, you have to put it out in front of the declaration. The declaration and the definition go together. There is no such thing as declaring a function anymore. You just go and define it immediately. So the list goes on. If you want to have another function, you'll have to declare it. It just finds them. So we'll talk about that in a second. But this is enough comments for now, I think. So that's hello world. So what happened is we made hello world.java. And that had public class hello world. And we gave that to Java C, which made hello world.class. That was the compiled form of that. And then we gave that to Java, which actually ran it. Okay, that is the idea. And we can look at what java.lang gives us. They give us very, very nice documentation. The Java standard library is huge. This is why people love Java. Though it is so silly the way that they choose their names. They are very long and very silly. Usually lots of capitals all over the place. But here's java.lang. Inside of that there is system, because that's where we had our print line, system. There's a bunch of other things. That's where string lives. And we had system.out, and system.out is a print stream. Go there. It's a print stream. What can a print stream do? Well, it's got constructors. It can print different kinds of things. It can print strings. It can print a string and then a new line. And that's the one we call this one right here. It's a void print line taking a string. That's what we did. So it's very terse. It's a lot, but that is Java in a nutshell. So before we go, let me talk about the main differences that might surprise you. So in Java, first of all, everything's a class. There are no pointers, and arrays have different syntax than in C++. So those are the big things that I want to hint on. But let's get started somewhere. So Java is something that it's a programming language that compiles to not really machine code. It compiles to like intermediate code that runs on what's known as a virtual machine. It runs on the Java virtual machine. So when you compile a Java program, those can run on any computer, in fact. And this is very, very different in stark contrast to when you compile a C++ program. And when you do that and you expect to run it, you can only run it usually on the same operating system and CPU architecture pair. Okay, so it's got to be an Intel machine running Windows, for example. You can't just go and put that on a Mac and expect it to run. Whereas in Java, you can expect it to run. It's a different kind of compiled form. Okay. Also, Java is known as garbage collected. So this is actually really nice for you beginning programmers, and this is exactly why we don't teach you Java, because you're allowed to say new, and then there is no delete in the language. It just does it for you. So obviously, we don't want to teach you that. We want you to manage your own memory right now and learn how to do that. So that's Java. Now, we already talked about why everything's a class. It's just, that's how it works. There are no pointers, though, which is very interesting. So let's talk about that. So let's do it in one fell swoop. Let's make a new file called simple example or something. More Java. And this is forced to be the name of the file, right? So I have to save this, and I have to call it morejava.java. If the file save dialog ever shows up. If this keeps on taking forever, I might have to, there it goes, morejava.java. And so now that's saved, and here's how you do it. You say javac morejava.java. And then you can say Java, more Java to run it. Okay, it's all the same as before. So now let's talk about arrays. So first, let's just talk about the things that are in common. Like ints are the same. Int x equals 42, that's fine. Double y equals 3.14, that's all the same. Booleans are a bit different. It's not bool, but boolean spelled out. True and false are the same, though. What else? We've got strings with a capital S. And now we have arrays. So let's talk about arrays. So first of all, everything that you make brand new, arrays included, are going to be on the heap, okay? All arrays are on the heap, which means even if they have ints inside of it, there are no local arrays anymore. You have to use new. And the syntax is slightly different. It's not int array blank blank equals 1, 2, 3. It's well, you got to move these first of all. It's int array arr, just like that, just like it's string array args, like that. And then we have to say new somewhere. We have to say new int and give the size. Usually, but sometimes we can just initialize it like this. Okay, so right now it's complaining, and Visual Studio is really nice because it does this kind of complaining for us automatically if we just install stuff. All these things are unused. All these variables are unused. That's why it's underlying them. But now we can do things as before, as normal. For loops exist in Java just as normal. You can say for int I equals 0, I is less than. How big is the array? Well, it's 3, but actually arrays in Java know their size. Dun dun dun. Array.length. I++. So arrays must all be made on the heap. The little brackets go after the type. And arrays actually know their length. It's arr.length, just like that. It's not even it's just a field. It's not even a method. So you can say, all right, system.out.println. You can say arr of I. Yeah, this will print out 1, 2, 3. And now it didn't. There's no more squiggles because we're using arr. The rest of these we haven't used yet. Okay, are you ready? Recompile. Rerun. Whee, 1, 2, 3. So that is arrays in a nutshell, and there's no delete necessary. Java takes care of that for us. It notices that we're done using it. And garbage collects it away. Ready to be used for some more stuff. Okay, so I think that's all I want to say today about Java, just to give you a little taste. And next week in our, I think this is about to be the Thanksgiving break, so it'll just be one lecture. I will go as far into Java as much as I can, and then we will, I'll at least give you a bit of a taste of Python so that you have them both under your belt a little bit. If nothing else, I'll give you some examples to take a look at. So that is Java. Yeah, hopefully that was fun. So we'll be back. We'll be back with more Java if you're interested in this. So I will see you then.